Today we are going to look at fractional exponents. First, before we do that, let's look at some things that we know to help us understand fractional exponents. We know that 3 squared equals 9, so it makes sense that the square root of 9 equals 3, or we could rewrite it as the square root of 3 squared. All of those are equivalent. Also, we know that 5 cubed is 125. That makes sense then that the cubed root of 125 would be 5. Or the other way you could write it as the cubed root of 5 cubed. Another idea, 2 to the 4th is 16, so it would make sense that the 4th root of 16 is 2. And another way to rewrite it is the 4th root of 2 to the 4th power. In general, for any x greater than 0, if you take the same root as the power that's on the x, you're just going to get x. And we've seen that with some problems that we have done before. Now, where it says definitions, okay, we just talked about this one right here. Taking the nth root of something to the nth power will just give you the x. Now, for the next piece, if I were to rewrite the nth root of x, I could write it as x to the 1 over n power. The 1 is in the numerator because the power on the x is a 1. The n is in the denominator because the root is an n. Another way to think of it, now x is to any power to the nth root. The power goes in the numerator, the root goes in the denominator. Another idea, this is the same thing except since it is a negative, or since it's in the denominator, it's going to be a negative power. If I were to go opposite, a negative power would be rewritten in the denominator. Let's try some examples here. It says express each power as a rational number in simplest form. Let's start by rewriting and then simplifying. 4 to the 1/2 power is the same as 4 to the first and then taking the square root. Well, the square root of 4 is 2. 125 to the 1/3 power is the same as 125 to the first and then taking the third root. If you were to type that in your calculator, it would give you 5. 8 to the 5/3 is the same as 8 to the 5th power, and then taking the cubed root. When you type that in your calculator, you get 32. And finally, 100 to the negative 3/2 power. Since it's a negative power, I'm going to write it as 1 over 100 to the 3/2. Remember from last time. Now, rewriting that as a radical, it's 1 over, it's going to be 100 to the 3rd power, and then that 2 in the denominator means a square root. Now, 1 over 100, the square root of 100 cubed is equal to 1 over 1,000. Next piece, write each radical as a power with positive exponents and then express in simplest form. Okay, radical 6. Well, right now, since you don't see a power on the 6, you know it's to the first power. And since you don't see a little number in front of the square root, it's just a 2 square root. So 6 to the 1/2. 15, the cubed root of 15. Well, the power on the 15 is a 1, and the root is a 3. So it's 15 to the 1/3. And 1/2 radical 9a to the 6b squared. I'm going to start by just writing this 1/2 here. The 9 is to the first power, and it's the square root, so 1/2. The a is to the 6th power, under a square root. And then the b is to the 2nd power, under the square root. Let's simplify those powers. 9 to the 1/2, if you type it in your calculator, it's 3. 6 divided by 2 is cubed. 2 divided by 2 is 1. Finally, 1/2 times the 3 is going to be 3/2 a cubed b. And moving down, going backwards, write each power as a radical expression in simplest form. Okay, so we have 5 to the 1/2 power. Well, that's 5 to the first and then taking the square root. The square root of 5 is just the square root of 5. This is 12 to the 5th power, taking the 4th root. Remember, 12 to the 5th power is like 5 12s lined up. The fourth root says take out sets of 4. Oh, you have 4 12s. You have an extra 12 left over, so 12, fourth root of 12. Next one here. Let's start by just rewriting these. 5 to the 1/3 is the same as the cubed root of 5. A to the 2/3 is the same as cubed root of a squared. They can go under one radical together. 4 to the 1/3 is the same as the cubed root of 4. And I'm going to actually leave it at that. We can rewrite it if we wanted to, though, as the cubed root of 5a squared over 4. I'm not going to worry about that is a fraction right now. At this point, oops, erase that. At this point, you can work on the 3 do now problems at the bottom.